We will use the squeeze theorem to show that the limit at x go to 0 from the right-hand side of the square root of x plus sine of 1 over x equals 0. Every time we use the squeeze theorem that involves sine and cosine, we would use this trigonometric identity. Sine of theta is between -1 and 1. It doesn't matter what theta is, even if theta is 1 over x. And so sine of 1 over x is between 1 and -1. We chose this inequality deliberately. We then build the expression in the limit from this inequality. To obtain the given limit, we just simply take these inequalities and multiply the square root of x to all three parts. Now, the square root of x is a positive number, so when we multiplied it, the inequality still holds. We end up with negative square root of x less than or equals the square root of x, sine of 1 over x less than or equal to the square root of x. Now there's only one thing for us to do here. We just simply put the limit in the front of each of these parts. The limit at x go to 0 from the right hand side of negative square root of x is therefore less than or equals the limit at x go to 0 from the right hand side of the square root of x, sine of 1 over x less than or equals the limit at x go to 0 from the right hand side of the square root of x. The nature of the squeeze theorem is that we won't be able to evaluate the limit in the middle directly, but we can evaluate the limit for the first part and the last part. At x go to 0, square root of x would go to 0. Negative 0 is still 0. And the last part, at x go to 0, from the right hand side, the square root of x also go to 0. Now, we rewrite the middle part. It is not that we evaluate the limit of the middle part, but we just simply rewrite it. Whatever the limit is, it is being pinned between two numbers, 0 and 0. And if it is being squeezed between 0 and 0, then it has to be 0. So the limit at x go to 0 from the right hand side, the square root of x, sine of 1 over x is 0. Now we know that this is what the graph of the square root of x looks like. And as we can see, at x go to 0 from the right hand side, the square root of x would go to 0. And the graph of negative square root of x also looks like this. At x go to 0 from the right hand side, negative square root of x also go to 0.